Hello everyone. Okay, so you might have seen my previous videos, or video, I guess it was just the one, of my first prototype trials that I was running on my senior design project for school. And essentially it is an ion engine, and that's this guy right here. And I apologize for the lack of professionalism in the video. I'm not much of a cinematographer, but you get what you get. So, but right here, what we have is a high voltage transformer connected to the across the electrodes of this ion engine here, and I won't go too deep into the physics behind it, but essentially the difference in size between the electrodes here and here basically makes it so that an ionizing reaction occurs between them and forces it rips electrons off the atoms in the air and pushes away these now positive ions and forces them out the back. And this design, by the way, is borrowed heavily from from other sources, and I'll definitely give them credit down in the description. But I have made some tweaks of my own, so including something I haven't seen done before, which is the inclusion of this anemometer rig. And the anemometer is, it's pretty straightforward. It's just designed to take velocity values, fluid velocity values. You can't really see it, but right there. And so whenever I turn on the circuit, it will actually the blades on the anemometer will rotate and pick up how fast the fluid, in this case air, is flowing through the ion engine. So needless to say, this thing, as you can see here, generates 12 kilovolts at 30 milliamps, and that is more than sufficient to kill you. So if you are taking any of my advice or trying to emulate anything that I've done or what any of my peers have done with similar projects, I urge you to be very cautious, of course. And again, that goes without saying, but I have to say it. So I will say something else that not a lot of other people really mention in any of their tutorials or guides, any of the ones I've seen at least. None of them, or pretty much all of them, fail to mention the simple fact that something that I ran into a lot, sorry, I'm going to try that again. Basically just the biggest obstacle that I ran into was this here transformer. Because the problem is, you need one like this. You need a ferromagnetic transformer, because a lot of the transformers, or pretty much all of the transformers that you'll find in any hardware retail outlet, will be electronic transformers. And this is just, I'm not positive on all the details, but I'm fairly certain that this is how it works. The electronic transformers are, they coincide with the regulations that were instituted about 15 years ago. There was an update of their safety regulations so that they would include an internal ground fault interference circuit that would trigger every time the circuit detected any sort of shorting or, of course, ground fault interference. If you use one of those electronic transformers, this will not work. They're pretty much like, this is a neon sign transformer, and the other transformer that I was using, I have it around here somewhere. I could just show it to you just for the sake of it. But this is the one I was using, and it is, as you can see, much smaller. Yeah, so essentially, just to get to the point, nobody really made it very clear in any of those guides that you don't want to use one of these, because they do include a secondary GFI protection, ground fault interference protection circuit, that will interpret the ionization reaction that occurs between the electrodes here as ground fault interference. So you definitely don't want one of those. You want one of these older models, which are much sturdier, much tougher, and they don't need the internal ground fault protection. So they essentially will not, there's no ground fault protection inside to get triggered by the ionization reaction occurring, or any arcing that might occur between the electrodes. So above all other things, just keep that in mind. Do not buy a new transformer from any retail outlet. Your best bet is a private collector or an electrician of some sort, somebody on eBay. That's where I got mine. So yes, that long-winded portion of the video aside, I will now show you exactly how it works. So yeah, so essentially the power gets fed in through this cable here, which is plugged up into the ceiling, these crazy outlets, and gets fed into this auto transformer here. And this naturally fluctuates between 0 and 100%, and 100% being 120 volts, which is the standard for all US power outlets. And so then the output of the auto transformer is right here, and that feeds, or that, unfortunately, the trigger, this trigger switch that I'm using, it's a pressure momentary on trigger. And that's just to make sure, it's sort of like a fail-safe, but essentially the plug is one of these weird diagonal ones, as you might be able to see over there. And so I can't plug it directly into here, so I had to kind of, kind of jerry-rig it. So I just plugged it into an alternative power strip, and then it just feeds back into the input gets fed into the pressure switch. And so every time the pressure switch is held down, it delivers power to the high voltage transformer, which then splits the voltage across the electrodes in the ion engine. Excuse me. So, yeah, all that crazy explanation aside, we're going to give it a shot. So, yeah. So, yeah, make sure everything's on. That's the big problem. Unfortunately, I need two hands to operate this auto transformer, because I need to push the switch down as well. But I'll use my elbow to push it down, and so now it's pushed down and power is being delivered to the circuit. So I'm going to amp it up, and you might be able to hear the ionization reaction occurring. I'm not sure how well it'll happen over video. But, ooh, and I forgot to turn on the anemometer. There it is. Yeah, it shuts off after a little while. Yeah, so power is being delivered to the auto transformer, or to the big transformer, and it's really making a lot of noise now. You probably can hear that. Okay, now we're at 100%, and we are getting a reading on the anemometer, roughly 1.2 meters per second. And as you can see, you might be able to see, the blades of the anemometer are spinning. Not really as dramatic as some other videos where, I could hang a piece of tissue paper behind it like a lot of other people do, but yeah, so, and I seriously doubt you'll be able to see it, but there is a very faint glow in between the electrodes. That's the ionization reaction occurring, and yeah, so that's it. Thanks for watching, and yeah, there goes power off, and power on, power off. Yeah, so thanks for watching. Hope you enjoyed. If you have any questions, just I guess send me a personal message or comment in the below the video, and I'm going to try and include some information about it in the description. So if I missed anything, I'm sorry. But yeah, thanks for watching, and be sure to like and subscribe if you so desire, and I'll be sure to make more videos like this in the future, because I'm going to be doing more projects in the coming future. So, you have a good day. Catch you later, guys.